Hi, today we'll be solving GCE 2023 Further Mathematics Paper 1. And since the paper consists of 50 multiple choice questions, we'll divide it into two parts. And in the first part, I'll be answering questions 1 to 25. And later on in part 2, I'll be answering questions 26 to 50. Okay, in the first question, we have x squared plus 1 all over 1 minus x squared, where x is different from plus or minus 1, expressed in partial fractions, where a, comma b belong to the set of real numbers is, and we have these options. So generally, this is a rational function with the degrees of x at the numerator and denominator the same. We have x squared at the numerator and negative x squared at the denominator. So if we are dividing that polynomial, the quotient will be -1 because the first term, the highest degree term at the numerator, x squared divided by the highest degree term at the denominator, negative x squared, would give us -1. And in all the options, we have D as the alternative which has that quotient as -1. If you would want to solve, then you start by factorizing -1 at the numerator. So you get -1 minus x squared, then divided by 1 minus x squared. And from there, I have -1 into, the strategy here is to express the numerator so that it should contain 1 minus x squared, which is at the denominator. So I'll put 1 minus x squared, and I still have -1 that is supposed to be at the numerator, and then I subtract 1 because I've introduced a +1 at the numerator, divided by 1 minus x squared, and we then have -1 into 1 minus x squared minus 2, so that upon simplification we can distribute the terms at the numerator. So this divided by the denominator, and then -2 divided by the denominator. So at the end, I will get -1 into 1 minus x squared over 1 minus x squared, which gives 1. So -1 plus -1 times -2, which is +2, divided by the denominator again, which is 1 minus x squared. Using difference of two squares, we have 1 minus x into 1 plus x. And of course, if you evaluate this second term, you would get a over 1 minus x plus b over 1 plus x, and then the -1 that is in front is subtracted. So it corresponds again to option D. In the second question, the integrating factor for the differential equation x dy dx minus 2y equals x squared is, and we have these options. So in this situation, we start by dividing through by x, so that we put the differential equation in the standard form, which is supposed to be dy dx minus 2 over x, y equals x. So the strategy here is to divide through by the coefficient of dy dx, so that the coefficient should be unity, and it puts the differential equation in standard form. When it's in this form now, the coefficient of y would be used in calculating the integrating factor, whereby I, the integrating factor, equals e to the integral of -2 over x, that coefficient of y dx. And this gives e to the -2 integral of 1 over x, which is ln x. This gives e to the ln x to the -2. Remember that e to the ln a equals a. So using that property, e to the ln of x to the -2 would simply be x to the -2, which is equal to 1 all over x squared, and that corresponds to option B. In number 3, we have that in exponential form 1 minus tanh x is identical to, and we have these options. This is about expressing 1 minus tanh x, which is in a hyperbolic form, into its exponential equivalent. So this should be equal to 1 minus tanh x is the same as sin x all over cos x, and that gives 1 minus e to the x minus e to the -x over 2 divided by e to the x plus e to the -x over 2. Over 2 cancels over 2, and we then have 1 minus, I can multiply the numerator and the denominator by e to the x, because you can see in the options we have but e to the 2x, so we can achieve the power of e to be e to the 2x by multiplying through the expression, both the numerator and denominator, by e to the x. So e to the x times e to the x will give e to the 2x. When you add the powers, e to the x times e to the -x would just be -1 all over e to the 2x plus 1. And when you find the LCM, you get e to the 2x plus 1 minus bracket e to the 2x minus 1 all over e to the 2x plus 1. And simplifying the numerator, we get 2 all over e to the 2x plus 1, which corresponds to option B. For the fourth question, we have which one of the following functions has a removable discontinuity? Questions involving removable discontinuity are common in further mathematics paper 1, and most of the time you have rational functions where the polynomial at the numerator has a higher degree than the one at the denominator, usually the one at the denominator being a linear function, although you could have cases of higher degrees. Now in the first part, the A part, there is discontinuity because if x is equal to -1, that function will be undefined. In the case of the second one, there is discontinuity because when x is 1, the function will not be defined. And in the case of D, the discontinuity value is x equals 3 because when x is 3, the denominator will be 0 and the function will be undefined. However, in the case of C, there is apparently a discontinuity value at x equals 1 because when x is 1, x minus 1 will be equal to 0 and the function will be undefined. However, in this case, we can simplify the numerator because it is factorizable, x plus 1 into x minus 1, difference of two squares all over x minus 1, and we can cancel that factor so that it disappears from the denominator. In this case, we now say the function has a removable discontinuity because the function has been simplified or redefined in such a way that the value that was causing a discontinuity at the denominator has been removed. So the correct option in this case is C. You can observe that in the other cases, the numerator cannot be factorized so as to cancel the denominator, which is causing the discontinuity of the function. In question 5, we have the series summation from r equals 1 to infinity of 1 all over r to the k is convergent for, and we have these options. This is actually a p series. Each time a series is such that uk is equal to 1 all over r to the k, like in this case, the series usually converges when the power of r, that is k, is greater than 1. So this series converges when k is greater than 1, and it corresponds to the option B. In number 6, we have that the argument of the complex number 1 plus e to the -2i is, and we have these options. So to find the argument of a complex number that is given in exponential form, is better we first express it in polar form or the trigonometric form. From here now, z equals tan inverse of the imaginary part, which is negative sine 2 theta, over the real part, which is 1 plus cos 2 theta. This will be equal to tan inverse of, actually sine 2 theta over 1 plus cos 2 theta is equivalent to tan theta. This is an identity in trigonometry. So you can actually prove that sine 2 theta over 1 plus cos 2 theta is tan theta by using double angle identities. So this always gives tan theta. So the negative sign will be brought down, and from there we have that. And since the tangent function is an odd function, I can also write negative tan theta as the tangent of negative theta. So from here we have that tan inverse of tan negative theta would just be negative theta. So the argument is negative theta, which corresponds to option B. In question 7, given the truth table below, the truth values of A and B are respectively, and we have these options. To have the truth value that B represents, we would have to look at the compound statement P or Q. It is generally false when both component statements are false. So since P is false and Q is false, the truth value represented by B would be false. Now we move to A. The truth value represented by A, we have to first look at what we have as the compound statement. It is an implication, which is P or Q implies Q. An implication would always be false if the premise is true and the consequent or the conclusion is false. In the line where A is, I have to look at the premise, which is P or Q. We see that it is true while the conclusion is false. So in that line, the premise is true and the conclusion is false. So this implies that the implication is false. So A is false and B is also false. That corresponds to option D. In the next question, we have let f of x equal the greatest integer function. Integral from -2 to 2 of f of x dx equals, and we have these options. So in integrals involving the greatest integer function, there are actually two methods. You can either do a piecewise breakdown of the function and then integrate individual functions within the given intervals, or you evaluate the integral using the graphical method by first sketching the graph. But generally, to sketch the graph, it may take longer. So we better strategize by breaking down the function into consecutive integers. So I have from -2 to the next consecutive integer, which is -1, and the function always falls down to the lower boundary. So I'll be integrating -2 dx in that interval, plus integral from -1 to the next consecutive integer, which is 0, and the function again will fall down to -1 dx in that interval, plus integral from 0 to 1, and the function will fall down to the lower limit, which is 0 in that interval, plus finally integral from 1 to 2 of the function, which will fall down to the lower limit in that interval, which is 1 dx. From there we evaluate the integral, so we have -2x from -2 to -1, plus integral of -1 is -x from -1 to 0, plus the integral of 0 dx is 0, so I ignore that part. Then I go to the last part. The integral of 1 dx is x, and we are taking from 1 to 2. When you evaluate all these, you get 2 minus 4 in the first integral, plus 0 minus 1 in the second integral, plus 2 minus 1 in the last integral. And all these give us -2 minus 1 plus 1, which is -2. And so the value of that integral is -2. But amongst the options, we don't have that result. However, to confirm that the result is -2, I would show you the second method, which is the graphical method. In the second method, which involves the graph, I would need to first break down the function into intervals, so some sort of a piecewise function. So in order to define these intervals, we have to break down into consecutive integer intervals. And you will remember the function always rounds down any real number to the greatest integer less than or equal to that value. So if I take an interval like -2 less than or equal to x less than -1, if the value of x in this interval is -2, then the integer, the greatest integer in that interval will just be -2. But any other real number in this interval that is not an integer will always round down to -2. And so we have -2 as the value of the function in that interval. When you take the next consecutive integer interval, which is -1 less than or equal to x less than 0, again the function will fall down to -1 in that interval. Then when you take the case of 0 less than or equal to x less than 1, the function will always fall down to 0 in that interval. And for the case of 1 less than or equal to x less than 2, the function again will fall down to the greatest integer in that interval, which is 1. So with this now we can be able to sketch the graph of f of x in the interval -2 to 2. So I have -2 and then -1, then 0, then 1, then 2 for x values, and then for y values we have 1, 2, and then -1, -2. So within the interval -2 to -1, the graph is a constant at -2. So where y is -2, the graph would start from where x is -2 included to where x is -1, boundary not included. So a horizontal line there would represent the graph. In the interval between -1 included and 0 not included, we are somewhere here. The graph is at y equals -1, a constant, and the boundary at -1 is included, while the one at 0 is not included. In the boundary between 0 and 1, the graph rounds down to 0, and so we have between 0, which is included, and the 1, which is not included, the graph is at y equals 0. And finally, in the x interval between 1 and 2, the graph is always at y equals 1. So where x is 1, the graph begins there and the boundary 1 is included, up to 2 where 2 is excluded. This is the graph of the greatest integer function between -2 and 2. To get now the integral of the function in that interval, -2 to 2, we're going to get the area enclosed by the curve and the x-axis. And this area is actually the resultant area. Any area that is above the x-axis will be positive, and you add it to the area that is below the x-axis, which should be negative. So actually we are dealing with the area enclosed by that line and the x-axis, which is 1 square unit. This other line is on the x-axis, so it doesn't enclose any area, while this other line encloses an area equal to 1 square unit below the x-axis, while this other line encloses 2 squares. You can see that from this bottom line to the x-axis there are 2 squares. So at the end I have 1, 2, 3, 4 squares, but there is 1 square that is above the x-axis, so that area will be positive, while 3 other squares are below the x-axis, so that area would be negative. At the end, the integral from -2 to 2 of f of x being the greatest integer function, the x would be equal to the area below the x-axis, which is -3, because it's below the x-axis. We have 3 squares there, so -3 square units plus the 1 square that is above the x-axis, making it -2 as the resultant area, which then corresponds to the integral of the function from -2 to 2. You can see again that the area is -2, as was confirmed in the first method. In question 9, we have that the root mean square value of sine x in the interval 0 less than equal x less than equal 1/4 pi is, and we have these options. So we need to know the formula for the root mean square value of a function f of x in the interval a to b is given as the square root of 1 all over b minus a integral from a to b of y squared dx. Applying the formula, we would have that the root mean square value should be equal to 1 all over the upper limit, which is pi on 4, minus the lower limit, which is 0, integral from 0 to pi on 4 of the square of the function. The function is sine x, so sine squared x dx. And since we have to take square root, it is simply all that to the power half. And from here, we have the reciprocal of pi over 4, which gives 4 all over pi, integral from 0 to pi over 4, sine squared x dx, all that to the power half. And when you take the square root of 4 at the numerator, you get 2 into 1 all over pi, integral from 0 to pi over 4 of sine squared x dx, all that to the power half. And this corresponds to option C. In number 10, we have the Cartesian equation of a curve whose polar equation is r equals 2a cos theta is, and we have these options. So generally, x squared plus y squared equals r squared in the polar system, and the r cos theta equals x in that system. So since we have r squared representing x squared plus y squared, which is appearing in all the alternatives, r squared equals 2ar cos theta. At this point now we can easily get the Cartesian equation. R squared is x squared plus y squared. That should be equal to 2a, and then r cos theta is x. When you look at all the options, you'll see that it is a that gives the correct answer. In the next question, question 11, the coordinates of the focus of the parabola y squared equals 16 into x plus 1 is, and we have these options. This is the case of a parabola whose vertex is not at the origin. The standard form is supposed to be y minus 0 all squared equals 16 into x plus 1. When it is in this form, you would first have to decide whether it is having a horizontal or a vertical axis. Generally, you observe the degrees of x and y to determine whether the axis is horizontal or vertical. If the degree of x is 1, like in this case, it means that the parabola has a horizontal axis, x, the x-axis being horizontal. You can easily remember when the degree of x is 1, the axis is horizontal. Remember from x, the x-axis, which is horizontal. When the degree of y is 1 in the parabola, then the axis of the parabola would be vertical in that case, just like y, the y-axis being vertical. When the degree of y is 1, the axis of the parabola would be vertical. It is important to determine the orientation of the axis because both the vertex and the focus all lie on the axis of the parabola and are separated by a units, where a is determined from 4a, which is always equal to the coefficient of x plus 1 there. So 4a is 16, implying that a equals 4. So now the coordinates of the vertex, I must first get them before I move to the coordinates of the focus. So that is generally what you will be doing. It is easy to read the coordinates of the vertex once the parabola is in standard form as we have it now. The coordinates of the vertex will be obtained by equating x plus 1 to 0, which gives negative 1 as the x coordinate, equating y minus 0 to 0, which gives 0 as the y coordinate. And as I already said, the vertex and the focus are separated by the distance a units, where a equals 4. The value of a being positive, it means this parabola with horizontal axis opens to the right, and so the vertex is a units to the left of the focus. So we will just need to modify the x coordinate of the vertex by adding a to it to get the x coordinate of the focus, while the y coordinate of the focus will remain the same since they all lie on the same horizontal line. And so my focus would be f into negative 1 plus 4, comma 0. And that gives the coordinates of the focus as 3, 0, which corresponds to option D. In question 12, we are given that 1 minus 4k cross 2i minus lambda j minus k is equal to negative 4i minus 7j minus k. The value of lambda is, and we have these options. So I would write the vectors in column form. The first vector is 1, 0, negative 4, and I'm crossing it with 2, negative lambda, negative 1, and the result is negative 4, negative 7, and negative 1. In order to easily get my lambda, I will do the cross product in column form. If I strike off the bottom row, I am eliminating the k components in order to get the 2 by 2 matrix determinant there, which will correspond to the cross product. So we have the determinant of that upper 2 by 2 matrix being 1 into negative lambda minus 2 into 0, the coefficient of k in the cross product, which is negative 1. And so negative lambda equals negative 1 follows that lambda equals 1, and that corresponds to option A. In number 13, a linear transformation T is defined as follows: T such that r squared is mapped onto r squared, xy maps onto x minus 2y, x plus y. The kernel of T is, and we have these options. Actually, you can answer this question without even doing the calculation, just by looking at the options. The kernel of T generally is the set of ordered pairs that would always map to the null vector under that transformation. And it is only in B that you have a set that is composed of ordered pairs. In A, we just have an ordered pair. In B, we have a set of an ordered pair. In C, we just have 0. And in D, we have a set of 2 elements which are all zeros. So the correct option, just by looking at the options without any further calculation, would be B. The set of ordered pairs is what the kernel of T should be. It is only B that is describing a set of ordered pairs. But to do the calculation, I have to look for the set of ordered pairs xy such that x minus 2y equals 0 and x plus y as well equal 0. When you solve this system, you can only have x equals 0, y equals 0. And so the only element in the set of ordered pairs that can give you the null vector under this transformation is 0, 0. And so as I already explained, it must be put in set brackets because the kernel of a transformation is a set. That is why it has to be put in set brackets. In number 14, given that the set A, B, C, D, together with the binary operation star, whose operation table is given below, is a group, then the identity element is, we have the table and then the options. Generally, to obtain the identity element from the operation table, we normally seek to find the element that operates with other elements and they remain unchanged. To look at that, I will look first at the rows and see where the elements of the set have appeared in the order given in the question, and we have it here. A, B, C, D has appeared at the bottom there. So under the element D, it operates with any other element and it remains unchanged. When you take it again vertically, you will see that the elements A, B, C, D appear under D, and so D is the identity element of that group, and that corresponds to D. In number 15, how many distinct solutions are there to the congruence 12x equals 15 mod 21? Generally, in a linear congruence like this, to get the number of distinct or unique solutions in mod 21, we simply find the GCD of the coefficient of x, which is 12, and the modulo integer, which is 21. The GCD of 12 and 21 is 3, and so we have 3 unique solutions or distinct solutions in modulo 21 for that linear congruence. The correct option then should be C. In number 16, the asymptotes to the curve y equals f of x, where f of x equals x minus 1 plus ln of the absolute value of x minus 2 all over x minus 1 are, and we have these options. In the case of functions which occur in such a way that there is the first part, which is a linear function, and the second part, which either has a log function or an exponential function, we can easily verify whether the linear function in the first term there is an oblique asymptote, and that is done by looking at the limit of this second part of this log as x tends to plus or minus infinity. You will discover that this function tends to 0 because the limit of x minus 2 all over x plus 1 is 1, and the ln of 1 is 0. So as x tends to plus or minus infinity, this part ln x minus 2 all over x minus 1 tends to 0. So f of x will then tend to this linear function x minus 1. It implies that y equals x minus 1 is an oblique asymptote to that curve. Next, to look whether there are other asymptotes, possibly vertical asymptotes, we look at the critical values of the argument of the log function that are there. So we have x minus 2 equals 0 will give x equals 2, and x minus 1 equals 0 will give x equals 1. All these critical values are points of discontinuity on that function, and so they are vertical asymptotes to the curve. So x equals 2 and x equals 1 are vertical asymptotes on the function generally. So we have D as the correct option, since y equals x minus 1 is an oblique asymptote, and the x equals 2 as well as x equals 1 are vertical asymptotes on that curve. In number 17, the statement x plus 1 equals 3 is true for A, all real values, B, at most one value, C, at least one value, D, just one value. So if the solution is that of real numbers, then we just have that x plus 1 equals 3 and x will be equal to 2, the only solution in the set of real numbers. So it has just one value as the solution. In number 18, a function f is defined by f of x equals negative x for x less than 0, 0 for x equals x, and x for x greater than 0. If you know the definition of the absolute function, this function is actually the piecewise form of the function absolute value of x. And absolute value of x, one characteristic about it is that it is symmetrical about the y-axis. So f of negative x would always give you f of x. And so that function would be an even function. When you look at the options that we have, which one of the following statements is true? We have f being odd. F is odd is wrong. F is discontinuous at x equals 0. No, f is continuous because the limit to the left of 0 is 0. The limit to the right of 0 is 0. And it corresponds to f of 0, which is also 0. So at 0, that function is continuous, not discontinuous. And the function being even, C should then be the correct option, since the function is not periodic. In number 19, the value of x for which sine inverse of 2x equals ln 4 is, and we have these options. To get the value of x, we start by taking sine of both sides, and the sine of the left hand side will just give you 2x equals sine of ln 4, so that we get the definition of sine x, which is half into, so sine of ln 4 should be e to the ln 4 minus e to the negative ln 4, and that gives you half into e to the ln 4 is 4, while e to the negative ln 4 is 1/4. So 2x is equal to all that crossing the cross multiplying. We have that 4x equals 4 times 4 is 16 minus 1. We have 15 all over 4 on the right hand side, so that x should be 15 over 4 divided by 4, which gives 15 all over 16, and that corresponds to option C. In number 20, a similarity transformation or a similitude f on a complex plane is defined by z prime equals 3 minus 4i z plus 1 plus I. Its scale factor is, and we have these options. So generally, when you have a transformation or a similitude of this nature, the coefficient of z, if it is a real number, then its absolute value gives the scale factor. If it is a complex number, like in this case, the scale factor k is simply the modulus of that complex number. So the modulus of z there should be 3 squared plus negative 4 squared, and that gives 5, corresponding to option D. In number 21, we have integral from negative 1 to 1 of x to the 9 minus x cubed plus tan x all over 1 plus x to the 4th all squared dx equals, and we have these options. So generally, when you see especially a complex integral which has limits of integration from negative a real number to the positive of that same real number, you verify quickly the parity of that complex function. If the parity is such that the function is an odd function, then the integral will be 0. But if it is an even function, the integral will reduce to twice the integral from 0 to the real number of the function given. If you verify well, you will see that x to the 9th, so this is an odd function since the power of x there is odd. X cubed is also an odd function since the power of x is odd. Tan x is a well-established odd function, and then 1 plus x to the 4th all squared is even, and it makes the overall term there to be odd. And so all the terms being odd means the whole function itself is odd. So you can actually show that f of negative x would be equal to negative f of x in this case, and so the value of the integral will be equal to 0, corresponding to option B. In number 22, the general solution of the differential equation d squared x all over dt squared plus 9x equals 0, where p and q are constants, is x equals, and we have these options. This is actually a differential equation that describes simple harmonic motion. The differential equation being homogeneous, we then have to start with the auxiliary equation, which is m squared plus 9 equals 0, implying that m squared equals negative 9, so that m should be equal to plus or minus 3i, which can also be written as 0 plus or minus 3i. So the general solution should then be x equals e to the real part there, which is 0 times t, into a cos the imaginary part there, which is 3t, plus b sine the imaginary part again, which is 3, and then t. And that gives us e to the 0, which is 1, and we are left with a cos 3t plus b sine 3t, which we can express in harmonic form as a certain constant p cos 3t plus an acute angle alpha, where p is simply the root of a squared plus b squared. So this form corresponds to option C. In number 23, the mean value of cos 2x in the interval 0 less than equal x less than equal 2 is, and we have these options. In the case of the mean value of a function, the formula is supposed to be mean value equals 1 all over the upper limit minus the lower limit integral from a to b of y dx. So we get b as 2 and a as 0, 1 over 2 minus 0, integral from 0 to 2 of cos 2x dx. This gives us half into, now cos 2x integrated gives 1 over 2 sine 2x, and we are taking from 0 to 2. That will be 1/4 into sine 2x is the same as e to the 2x minus e to the negative 2x, all that over 2 with limits from 0 to 2. That gives 1 over 8 into the substitution of the upper limit 2 gives e to the 4 minus e to the negative 4, and the substitution of the lower limit 0 gives e to the 0 minus e to the 0, which is 0. And so the correct answer will be 1 over 8 into e to the 4 minus e to the negative 4, which corresponds to option B. In number 24, we have a curve is given in Cartesian form by the equation x squared plus y squared plus 2y equals x squared plus y squared to the power half. The polar equation of the curve is, and we have these options. X squared plus y squared always corresponds to r squared in the polar system, so the left hand side will be r squared plus 2, and y in the polar system is r sine theta equals r squared raised to the power half. When you take the right hand side, x squared plus y squared is r squared raised to the power half. Now you get r squared plus 2r sine theta equals r, and you can divide through by r to have r plus 2 sine theta equals 1, so that r equals 1 minus 2 sine theta, giving the polar equation of the curve, and that corresponds to option B. In number 25, we have that if the asymptotes of the hyperbola x squared over 16 minus y squared over a squared equals 1 are perpendicular, then the value of a is, and we have these options. So in the case of a hyperbola whose center is at the origin and the axis horizontal, we have the standard equation x squared over a squared minus y squared over b squared equals 1, and the equations of the asymptotes are given by y equals plus or minus b over ax. In order to find the value of a for which the asymptotes are perpendicular, I will need first the gradients of the asymptotes. The first gradient m1 corresponds to positive b over a, and b is the square root of a squared there, which is a, while a is the square root of 16, which is 4. So a over 4 is the first gradient, while m2 now is the negative of that, which is negative a over 4. Now for two lines to be perpendicular, the product of their gradients must be equal to negative 1. It follows that a over 4 into negative a over 4 should be equal to negative 1, so that a squared will be equal to 16, and then a equals 4, corresponding to option D. Thanks for watching, and as I earlier said, we have simply done half of the paper, the first 25 questions. In the next session, I'm going to do questions 26 to question 50. And please, if you are new to the channel, subscribe and activate the notification bell so that anytime we upload any new videos, you will be able to get the notification and watch. Also, share to your friends and classmates so that they get to know more about the channel, which has a lot of resources for your GCE examinations.